Question 1. In which of the following will hydrogen form ionic compound? Ionic compound exists between metal and non-metal. Option A. Hydrogen is a non-metal and chlorine is a non-metal as well. So option B, sodium is a metal while hydrogen is a non-metal. So ordinarily we'll just stop there. So option B will definitely be the answer. If you want to know more about ionic bond, then you can check out this video. Ionic electrovalent bonds are formed between two kinds of atoms having large electronegative difference. That is, the electronegative difference greater than or equals to 0.8. For example, element X having electronegative value of 1.2, while element Y having electronegative value of 3.0. The electronegative difference is equals to 3.0 minus 1.2. Therefore, we have 1.8. Since 1.8 is greater than 0.8, anytime electronegative difference is more than 0.8, ionic form between X and Y. It also exists between metal, which usually lose electron, and non-metal, which usually gain electron. Magnesium, a metal, losing 2 electrons to become magnesium ion. And a chlorine, a non-metal, accepting 1 electron to become chlorine ion. We then have magnesium chloride. Question number 2. If the volume of a given mass of a gas at 0 degrees Celsius is 29.5 centimeter cube, what will be the volume of the gas at 15 degrees Celsius, given that the pressure remains constant? Looking at this, we'll realize that since we are given the volume and we are given the temperature as well, so and the pressure remains constant, then you should know that we should be dealing with what is called the Charle's law. V1 is equals to 29.5. The T1 is given as 0 degrees Celsius. Is changed to Kelvin by adding 273 degree Kelvin with it. V2 is what we are looking for. T2 is also given as 15 degrees Celsius. We change it to Kelvin by adding 273 with it. So it gives us 288 Kelvin. So using the formula V1 over T1 is equals to V2 over T2. We cross multiply, and at the end of the day we get V2 is equals to 31.1. If you want to read more about Charle's law, you can watch the video. Charle's law states that the volume of a given mass of a gas is directly proportional to its temperature, provided the pressure remains constant. Mathematically, volume is directly proportional to the temperature. Volume is equals to the constant K times temperature. The constant K is equals to volume over temperature. Therefore, V1 over T1 is equals to V2 over T2. The graph of Charle's law. Okay. The volume there is in centimeter cube, it's on the y-axis, while the temperature is in the x-axis and is in Kelvin. So the graph itself is linear. This is also for the Charle's law. The volume there is also in centimeter cube. Why you have the temperature is there is in degrees Celsius. The first one we did is in Kelvin. Note the difference between the two. And we have the absolute zero temperature is at minus 273 degrees Celsius, which is 0 degree Kelvin. So at a temperature of absolute zero, there's no motion and there's no heat. Question 3. The reaction below represents neutralization reaction. In which of them is the value of change in enthalpy highest? We shall require the knowledge of strong acid, weak acid, strong base, and weak base. Option A, we have propanoic acid. It's a weak acid, while potassium hydroxide is a strong base. Option B, we have ammonium hydroxide. It's a weak base, while hydrochloric acid is a strong acid. Option C, we have sodium hydroxide. It's a strong base, while hydrochloric acid is a strong acid. Option D, we have ethanoic acid. It's a weak acid. In fact, all organic acid are weak acid, and sodium hydroxide is a strong base. So out of the option A to D, option C is the only one that have a strong acid and a strong base. So option C will be our answer. To know more about strong acid, strong base, weak acid, and weak base, you can check out this video. An acid is a substance which interacts with water to produce hydrogen or hydrozonium ion. Hydrogen ion, hydrozonium ion. Okay, the hydrogen ion is equals to the hydrozonium ion. They are the same thing. Strong acid ionizes completely in water. Examples of strong acids are hydrochloric acid, tetraoxosulfate 6 acid H2SO4, trioxonitrate 5 acid HNO3, hydroiodic acid HI, hydrobromic acid HBr. Its ionization in water is given thus: hydrogen chloride with water, it ionizes to become hydrozonium ion and chlorine ion. The same thing, sulfuric acid H2SO4 with water ionizes to become hydrogen ion and tetraoxosulfate 6 ion. A weak acid ionizes partially in water. Examples of weak acids are ethanoic acid, triazocarbonate 4 acid, hydrofluoric acid. Ionization in water is given thus: ethanoic acid, when it is dissolved in water, it gives ethanoate ion and hydrogen ion. Same way, hydrogen triazocarbonate 4 dissolves in water to give hydrogen ion and triazocarbonate 4 ion. Let us look at base. A base is a substance which interacts with water to give excess hydroxide ions in an aqueous solution. For example, ammonia is a base. It interacts with water to give ammonium ion and hydroxide ion. A strong base ionizes completely in water. They are hydroxides of alkali and alkali earth metals. Examples are sodium hydroxide, which is also known as caustic soda, potassium hydroxide, also known as caustic potash, barium hydroxide, calcium hydroxide, strontium hydroxide, lithium hydroxide. A weak base ionizes partially in water to produce hydroxide ions. Examples of weak bases are ammonia, ammonium hydroxide, iron 3 hydroxide, aluminum hydroxide, lead hydroxide, copper 2 hydroxide, and zinc hydroxide. Question number 4. The pollutant usually present in a city which generates its electricity from coal is option A, fog, option B, carbon 2 oxide, option C, smoke, and option D, sulfur 4 oxide. So sulfur oxide is the solution. So if you want to know much about the air pollutant, you can watch the comment video. We shall be looking at air pollution. What is air pollution? It is the process of releasing harmful substances into the atmosphere. Air pollutants can be grouped into two classes: solid air pollutants and gaseous air pollutants. Solid air pollutants are dust, soot, lead dust, radioactive materials, pollen grains, spores of bacteria and fungi. Gaseous air pollutants are sulfur 4 oxide, oxides of carbon, CO and CO2, oxides of nitrogen, NO and NO2, and chlorofluorocarbons. We shall take them one by one, how they are formed and the harm they caused. Number 1, carbon monoxide, CO, colorless gas, insoluble, and no smell. How is carbon monoxide formed? It is formed when the carbon compounds in fossil fuels burn in too little air. For example, inside car engines, generators, and furnaces. What harms does it do? It is poisonous even in low concentrations. It reacts with the hemoglobin in blood and prevents it from carrying oxygen around the blood, so you die from oxygen starvation. Sulfur dioxide, SO2, an acidic gas with a pungent smell, forms when sulfur compounds in the fossil fuels burn. Power stations are the main source of these pollutants. What harms does it do? It irritates the eyes and throat and causes respiratory breathing problems. It dissolves in rain from acid rain. Acid rain attacks stonework in buildings, especially limestone and marble. They are calcium carbonate. It lowers the pH in rivers and lakes, killing fish and other river life. It also kills trees and insects. Nitrogen oxides, NO and NO2, acidic gases. This form when the nitrogen and oxygen in air react together inside hot car engines and hot furnaces. What harms does it do? It causes respiratory problems and dissolve in rain to give acid rain. Lead compounds. How are lead compounds formed? Compound called tetraethyl lead used to be added to the petrol to help it burn smoothly in car engines and as anti-knock. On burning, it produces particles of other lead compounds. It is also from lead acid battery manufacturing company. What harms does it do? Lead damages children's brains. It also damages the kidneys and nervous system in adults. Carbon 4 oxide, CO2, a colorless and odorless gas, slightly soluble in water. How does it formed? CO2 is generated by complete combustion of fossil fuel. What harms does it do? It helps to retain a certain amount of the infrared rays that is radiated by Earth. This gives rise to greenhouse effect, a gradual warming of our planet, that is the global warming. So, greenhouse gases are carbon 4 oxide, methane, and water vapor. Chlorofluorocarbons. How does it formed? Refrigerators, air conditioners, different types of sprays, fire extinguishers, and paints release chlorofluorocarbons in the air. What harms does it do? It combines with oxygen, causing ozone layer depletion, thus increasing the ultraviolet radiation in the Earth's surface, therefore posing danger to human health and cause an increase in cataracts, skin cancer, and sunburns. Hydrogen sulfide. How does it formed? From oil and natural gas extraction and processing, and natural emissions from geothermal fields. What harms does it do? It causes irritation to the eyes and respiratory system, convulsions, dizziness, and headaches. To eliminate hydrogen sulfide in water, oxidation is the most common form of treatment used. A chemical, sulfur dioxide (SO2), is used to convert the dissolved hydrogen sulfide gas into forms of sulfur that can be easily filtered from the water. Question number 5. The dehydration of butanol will give. Dehydration simply means removal of water, and the dehydrating agent, the commonly used one, is H2SO4. To be more clearer, we need to write the structural formula of butanol. Okay? The first carbon there, we can say from left, the second carbon, the third carbon, okay, and the hydroxide is in the last carbon, or we can say is in the first carbon from the right. Water is simply the hydrogen ion and hydroxide ion, and those are the two things we want to remove from the butanol. So let's remove the hydroxide there from the first carbon there, and hydrogen from the second carbon. Now the water has been removed, and the first carbon there and the second carbon there, the hydroxide and hydrogen that is removed there, will now give us another bond there. So we now have the double bond between the first carbon and the second carbon there, and that gives us alkene. And so it is known now that dehydration of alkanol usually give alkene. So in this case now, we now have what is called but-1-ene. Now, the condition at which this will happen, it will happen dehydration of alkanol to give alkene. It will happen at the temperature of about 180 degrees Celsius. And if it happens at a temperature that is lesser than that, like 140 degrees Celsius, it is going to give us alkoxy alkane.